Hi, do you have a manuscript? 2 or many unpublished manuscripts? Do you want to learn how to self-publish on Amazon? Search no more. Just send me a DM on my WhatsApp. Let's get started right now. Hi, you're welcome back to my YouTube channel. This particular channel is about chemistry. If you're still yet to subscribe, please do hit that subscription button and then press the notification bell so that anytime I post any content, whether it has to do with chemistry, whether it has to do with anything, you will get it, and then you have your choice. And then for my returning subscribers, please, thank you so much for returning constantly. I love you. Thank you. Well, today's topic, we are still on separation of mixtures. So let's get started.
Over the horizon, over the horizon.
Hi, you're welcome back. So like I said, we are still under separation of mixtures. Remember, I said that there are 15 methods of separating mixtures. So far we have discussed 8. Today we are going to discuss 4 more. So we start with crystallization. Crystallization. Now, when you talk of crystallization, you talk of crystals. It has to do with crystals. Now, this particular method is used to separate salts which decompose on heating. Remember, in the last topic we talked about evaporation, which is used to separate salts which do not decompose on heating. Strong salts, headstrong salts, no matter what you do to them, they can never decompose. That's for evaporation. But for crystallization, they are jebel salts now, that when you have to handle them softly. So that is they are the salts used where that, and crystallization is used for recovering. Now, for example, and these salts, when they are very pure, when recovered, they are very pure, and they always come with water of crystallization. For example, we have copper 2 tetraoxosulfate 6 pentahydrate, copper 2 trioxonitrate 5 trihydrate, and iron 2 tetraoxosulfate 4 heptahydrate. These salts are recovered using the process of crystallization. Now, how does this work? First of all, you heat that salt solution. Heat it, not heating it in such a way that it is do or die affair. Remember, they are jebel salts, so they decompose on heating. So you just heat in order to remove small solvent from the mixture, from the solution. Then once it reaches a saturated solution, you stop. That is when it reaches 100 degrees, you stop, and then you allow the solution to cool. As it cools, crystals are being formed. Now, these crystals can be induced with 2 methods. The first method is by adding crystals of the same salt into the solution. This can form more crystallization. That's form more crystals, make more crystals to be formed faster. Also scraping the inside of the vessel containing the solution. This also induces what? Crystallization, and produces more crystals and makes it to be faster. This method is used in industries where pure substances need to be produced. For example, drug industry and sugar industry, they normally use this crystallization method. So that's all about crystallization. Then fractional crystallization. Now, this is used to separate different solutes of roughly equal quantity present in the same solvent. Yeah, different solutes, they are roughly, they're not exactly the same quantity, but they are different and they are present in the same solvent. And the chemistry behind this is that these solutes must have different solubilities at different temperatures in the same solvent. So their solubilities must be different at different temperatures in that same solvent, so that when the crystals are cooled, that's when the mixture gets cooled and the crystals start forming at a particular temperature where of solubility for each of that solute, they will now come out. That when it reaches their own temperature of solubility, they will now come off, leaving behind the others which are still within the limits of their solubility. Just like when you enter in a public transport, many people enter public transport, right? You're not the only one they are carrying. Many of them, when it reaches your destination, you come out, and then leave the others. When they reach their destination, they will come out. It's just the same principle that is applied here. Okay, they have different solubilities at different temperatures. So when as it is cooling, at the temperature it has been heated, because we want to separate, it has been heated, it's now cooling. Now at this particular temperature, where the crystals have been cooled enough, they cannot stay further. That particular solute, because remember there are different solutes in a particular solvent. At the temperature of the when it reaches the temperature of solubility of that particular solute, it will now come off, leaving behind the others. When it reaches another one's temperature of solubility, that person will, that other, calling the human beings, that other solute will come out, you know, and so on. So that is how this fractional crystallization function. Then the next one is precipitation. Precipitate some, you know, precipitation normally has to do with things that are insoluble. They precipitate out, you know, they cannot dissolve, they precipitate. So this uses a difference in the solubility of a solid in two different mixable liquids. A difference in the solubility of a solid in two different mixable solids. For example, two liquids can be mixable. Both of them are mixable. They can dissolve. They mix in each other. They are soluble in each other. This solute can only be soluble in one of them and insoluble in the other. That is the chemistry here. Okay, this solute can only be soluble in one and insoluble in the other. For example, let us use iron 2 tetraoxosulfate 6. Okay, now this iron 2 tetraoxosulfate 6 is soluble in water. So it is in water and you want to separate it from that water, and you are using this process of precipitation. Ethanol is soluble in water, but tetraoxosulfate 6 is not soluble in ethanol. What do you now do? You add ethanol into this mixture of tetraoxosulfate 6 and water. Since tetraoxosulfate 6 is not soluble in ethanol, it now becomes disturbed. It's no more comfortable. What does it do? It will now precipitate out. It will now do what? Precipitate out, because you have added a sort of discomfort to it, which is ethanol, Ethanol will mix with water immediately, but it will cause problem for tetrodosulfate 6, which was also already so comfortable with water. It will now make it to come out from your comfortable position by precipitating out. And when it becomes precipitated out of that solution, it can now be separated by filtration. So that is how precipitation works. And the last but not the least for the one we have today is distillation. Distillation. Distilling things. You know, there's always a difference. Distilled water and filtered water, they are not the same. You can drink filtered water, but you cannot drink distilled water. Okay? Now, distillation is used to recover a salt, because why I explain is that most people normally confuse both of them or just see both of them as the same, but they are not the same. They are very, very different. Okay? So distillation is used to recover a solvent from a solution. It is used to recover a solvent from a solution. It's also used for separation of mixable liquids with widely undue far apart boiling points. Okay, in this particular situation, temperature is usually needed. Now, for this distillation, what happens? You boil the mixture, you heat up the mixture. I will show you the diagrammatic representation in the board. You heat up the mixture and then allow the vapor, give provision for the vapor to move out of the mixture. It is now collected. The vapor is now, as it cools, the vapor is now collected along a condenser. This condenser is also cooled again by tap water, because it is ensconced in an outer jacket. This outer jacket contains tap water. So as the vapor is moving down through that condenser, the tap water, due to the effect of the cooling tap water, will cool it more, which now turns it into liquid. So from gas, steam, vapor, it now turns into liquid. And then this liquid is now collected in a conical flask. And that liquid is called the distillate. It's the pure water. It's the water that has been separated from that impure water. From that mixture, we now separate this solvent, pure solvent, from that solute, from the mixture of solute and the solvent. So that is for distillation. Where do we normally use distillation? It is normally used in gin and water distilleries to produce gin and water. You all know what gin is, a form of alcohol. So we use distillation process to be able to produce gin. Now the diagrammatic representation. So this is distillation of water, the diagrammatic representation of distillation of water. Like you can see it as the apparatus has been set up. This is the triple stand through which the heat will be on. It heats the flask which is containing the impure water. Like I told you, it is used to recover the solvent from solution. So this is the impure water. Now we want to recover the pure water from this solution. So when it gets heated up, when the solution gets heated up, look at the vapor. Okay, the vapor is formed. Now this vapor is collected through here, and into this vaporizer. It now enters here. Now this is the live bank condenser, which contains the tap water, which also vaporizes and cools it more, which cools it more, and then it turns to a liquid. Yes, steam. Steam now being collected as vapor into the live bed condenser, which will now cool it more and turn it into a liquid. So this is the live bed condenser, and this is the vapor that has been collected and is now cooled into liquid. This is where it is now collected. This conical flask is now used to collect it. This is the pure water, and that is the distillate, just like I explained to you. So we've come to the end of this particular topic discussion today. These 4 methods of separation of mixtures: crystallization, fractional crystallization, distillation, and precipitation. Just don't forget to subscribe, hit that thumbs up figure there, and then comment. Thanks for watching. See you next time. Bye.